Right, we're about ready to start day 3 here of Advent of Code. Meantime, I've been like, I don't know, I haven't been that satisfied with VS Code. Like, it's got a couple of cool features, but it's so hard to edit text in. I hate it. And I can't run GHCI that easily, and I can't switch between like, I don't know. I just have to learn a whole bunch of different key bindings to do anything, and like, it doesn't indent right. I don't know. I think I'm just gonna do it in Emacs. But I'm like, what the hell is going on? I've got this like above. Oh, is that just a really bad? It is. Oh, I see. I can't even. Okay, I don't know. Maybe you guys can see that. I can't read that text. It just looks like there's a blank white bar at the top of my file. I wonder if there's a way to turn that off in language server mode. Let me check real quick. Language server mode, Emacs, disable, breadcrumbs? Let's just see if there's anything. Bread crumb? LSP header line breadcrumb mode. Control PB. There, okay. Cool. Is it? I think control backslash is what I put the all the LSP features on, but I don't remember what any of them are, so. Okay. Is it 9? It's 9. It's after 9. So, we might as well just get going on day 3. This time I don't have 20 minutes of yesterday's stuff to talk about. So let's just get started. Oh, we could look at what this picture is, by the way. I guess this is the water and we're being submarine-y, I guess? Okay. Anyway, day 3. Binary Diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and epsilon rate. Power consumption can be found by multiplying them. Okay. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. Okay, so we kind of like, these are our numbers, you know, rows. And each column, we look and see which number occurs most often. So here it's 1, for example, in the 3rd digit. And here it's, well, there's 1, 2, 3, 4, 5 zeros and 3, 6, 7 ones. Yes, okay, fine. Epsilon is similar, but instead of the most common, it's the least common. So you don't actually have to do least common and most common. It'll just be the opposite of the first bit. Of you know, gamma and epsilon will be opposite of each other. So sure. I'm just thinking about, like, obviously we kind of want to transpose this list of numbers, don't we? We're given rows and we want columns. And that's just transpose, which should be in Haskell. And at that point, we can fold over the column to find the most common number, and I guess the least common will have both pretty easily. Okay. That seems fine. So, back to Emacs, I guess. Let's get to it. I shouldn't need applicative do. I mean, it will be annoying that the VS Code won't automatically do imports for me, but in exchange for being able to actually like use the keyboard, I'll take it, I think. What do we need? Let me just first see, I guess I need DHCI basically, right? So import data list transpose, does that exist? Yes. If I transpose, you know, 1, 1, 1, 2, with like 2, 0, 3, I get exactly what I would expect. 1, 2, 1, 0, and 3, and 1, 3. Okay, cool. So we're gonna need transpose. And how do we parse? Well, okay, here's another question. What should be our list of inputs? I think it should be a list of bit, probably. Or should it be a list of binary? We'll make it a list of bit because, yeah, okay. And let's define data bit is 0 or 1. Deriving show, I guess. I probably want like ord even, don't I? Yeah. Peak ord show, because one simple way to implement like least and most common is to just like put them in a map. So import data map strict, I guess. Qualified as M. That's legal, right? Oh. I knew you could write this in some cases. I didn't realize it was a language extension. And like I've always written import qualified like this, and I hate it. And I saw someone write it the other way, and it's like, oh, you can write it the other way. But apparently, only if you turn on some language extension. Import qualified data map strict as M. I don't know. Is this really like even that good? I kind of had this other idea first, which is to define a frequency, right? There's a frequency of ones and zeros, both of type int, deriving, well, I guess not deriving, but we can we'll just define a monoid instance for this because it'll be nice to have. Instance semigroup freak where freak 01 OZ appended to freak of PX is freak of, this is just pointwise basically, O plus P and Z plus X. Yeah, so that compiles okay. It's just mad that our input type doesn't match what's here, which is fine. The idea is, oh, and then instance monoid freak where mempty is freak of 0, 0. So my idea is it would be sort of nice to just like compute the sums of both things at once by folding over the list, but rather than writing like a foldr, I'd rather use like fold map, which is the kind of, I think, nicer operation when you can do it. And the data that we have to keep as we're iterating over the columns of binary numbers has a monoidal structure, and so it's sort of nice to write it out. Right? It has a default, which is you start with 0, and a commutative operation, which is to like add together two things. And if we can just map our bits to freaks, then we can fold map to add them together. So I think this is sort of nicer than using data map. But I'm sure it'll take more lines. Okay, so let's write our prepare function first, because we want to produce a list of input. So it's so we're mapping some function to bits over each line, where actually better would be map of map to bit, where to bit of 0 is 0, to bit of 1 is 1, and the others are impossible. Like, okay. So if we were to, for example, just check real quick, what is prepare of 0, 1, 1, 1, 0, 1. We get 0, 1, 1, 1, 0, 1. Great, that's what we wanted. So we've got kind of our prepare thing written, and now we just need part 1 written. We'll probably also want a function that turns a list of bits into a number, which is easy enough. As number, list of bit to int, and as number should just be like a fold R, I assume, right? Not anything fancier to do. We're going to start with the most significant bit, so is there some smarter way? I don't think so. As number equals fold R go, where go of n and ACK is the result of calling, hey Mark, ACK is the result of calling of folding up the rest of the inputs, right? Oh, it's kind of hard to do this with a fold R. I think it has to be a fold L, actually. Flip these two. So now, in this case, the accumulator is what we've gotten so far, and it's the left part of the number. It's pretty easy. We multiply by 2 times ACK plus n. And no, not ACK, not n, because our n is a bit. We'll just call this function bit of b. And I guess I probably want bit to be a top-level function. Oh, bit is actually... bit is 2 enum, isn't it? I always forget if it's to enum or from enum. What's the difference? Ah! What button did I... okay. Show me... I have to import fold L prime. Yeah, you're right, I don't need those. Alright, well, as long as you're still coming here to the chat to hang out. It's just a pure functional programming language where you define lots of types. What is there to know? Ha ha ha. Okay, so what is the friggin' type of 2 enum? Will you please tell me? How do I ask the language server for the type of something? Like that? So if I search this for type, no. So we can describe freak in a second. I'm like, how do I ask LSP for the type of a damn type? There's nothing. Ooh, what button was that? That wasn't the button I wanted. No, so freak is actually very, very simple, right? You might, okay. The instances might be more exciting, but the point is we want to collect as we're going to scan over a list of bits at some point, and we want to keep track of how many ones and how many zeros we found. And so that's all this is. It's just a record. A freak is a tuple, sort of. It has 2 fields, ones and zeros, and they're both of type int. And that's really all this is. And we've defined how to combine 2 smaller freaks into a larger freak. Where we say, of course, if you have no freak at all, there were 0 of everything. And if you want to combine 2 freaks, we just do so pointwise. Add together the number of ones in both, add together the number of zeros in both, and that's the sum. That's really all we've done here. You can see it in action if we were, oh, but type, something else doesn't type check, so you can't. What exactly is it mad about here? List of bit to int, list of int to int. Okay, so I do have, I think, did I have this wrong? Is it? Actually, just tell me what is the damn type of 2 enum? Int to a. So I want from enum. Okay, that's better. This operator here is the, well, we can ask, right? Type of append. So append just takes 2 things which are, so semigroup and monoid are kind of like the most basic, what's the word I'm thinking of? They're a very fundamental level of composing data. You say, I have 2 things of the same type and some way to combine them. And that's like basically what semigroup is. So for example, like we can say like strings. How do you combine a list of strings? ABC and DEF. You combine them by just like concatenating them. And there's important properties that that semigroups have. Basically, it's just like the operation has to be associative, so it doesn't matter whether you write like X, Y, Z. That has to be the same as writing X, Y, Z. This is like the main semigroup law. You have to be able to compose things and not care about the parenthesization. And semigroups are everywhere. There are so many types which are semigroups. Technically, a semigroup isn't a type. It's like a type and an operation on a type, but most of the time in Haskell, it corresponds to a type, so we can talk about it that way. You know, lists can be added together in this way. Integers can be added. If you have, like, 0 is the default value, and plus behaves this way, times behaves this way. There are so many functions that work this way. And a semigroup instance for your own type is telling all the functions in Haskell that know how to operate on semigroups how to operate on your thing as well. So, for example, we can say well, we don't quite have enough stuff written down to show you how it works very well for freak. But for example, I mean, we can I guess do a little bit. We can say, you know, freak of 1, 5 composed with freak of 4, 9, right? And we get, oh, we have to give it a show instance. Fine. But it says, oh, I found 5 ones. You added together the 1 and 4, got 5. I added together the 5 and 9, got 14. And that's all we've done by defining this stuff. My plan is to use this to count the numbers of zeros and ones as we go through a list. There are other ways you could do this that would be shorter, for sure. For example, we could just have a tuple of sum of, we could tuple together a sum of int. And I don't know, that's like a little bit unnecessarily fancy. I have been criticized in the past for doing that when something straightforward would be simpler. But semigroups and monoids are everywhere. I think if there's like one interesting type to learn about Haskell that you can apply in other languages, I think I would suggest monoid and semigroup. You know, monads are the popular one, but they're kind of more advanced and more complicated. And it's more advanced to define your own, whereas you can just like, monoids and semigroups just show up all the time, and recognizing when you're doing something with them is kind of nice, I think. Anyway, so what we can do now is say, so we've got our input parsed, we have a way to turn a list of bits into an int, we have transpose. So we should be pretty much done, right? So part 1 is going to produce an int. Well, I mean, we definitely want it to produce an int, but it kind of has to get a pair of ints at some point, because won't this just count ones, though? That's an interesting question. I wonder why you think that. Won't what just count ones? Maybe I got something wrong? I don't think so. So let's write out a function here, counts. Bit counts. Takes a list of bit and produces a freak. I hope we can all agree this will be a useful function to write, to have in hand. Bit counts is just going to be fold map of toFreak, where toFreak of 0 is freak 0, 1, and toFreak of 1 is freak 1, 0. So this all compiles, which is nice. And if we say, I have a way to produce bits very well. I don't, but it's fine. If I say bit counts of, you know, 0, 1, 0, 0, 1, 0, we should see 4 zeros and 2 ones, right? And indeed, this is what we get. So I mean, you say that won't freak just count ones, and I don't really understand enough about what makes you ask that question to answer it. Freak is a type with 2 fields, ones and zeros, and they're both of type int. And the default value for both of them is 0 here. But our combine function combines them pointwise, adding the number of zeros together and adding the number of ones together. And so when we write bit count, we can fold map over it and add either to the zeros if the input was a 0, or to the ones if the number was a 1. So, what do we have now? Now we have... We're getting, like, closer. So So we could, for example, write, we have bit counts and we have a way to get a list of bits. We have a list of bits. So at some point we're going to go on to write. So let's try some whole-oriented programming here. Part 1 of nums is some function. I don't know what it's going to be yet. Applied to, oh, and by the way, this has to make an int, let's say. Applied to map my input is what again? It's a list of bit. So map bit counts over transpose of nums, right? So that's like almost correct, but I'm not done yet. And it's saying, great, you wrote that function, but you didn't finish it. You use this underscore, which needs to be a function from list of freak to int. And there's some way to... Yeah, I just don't have enough space at the bottom of the window to show, like, the output of this thing. Maybe I should use VS Code. So we have a list. We have a list of freaks now, which is, in fact, you know, we could do something interesting like this, and we could just say, just output the list of freaks. I'm gonna need to download my input first. There. So if we were to run input.txt, what would we discover? Yeah, we have a number that's, you know, I'm not sure exactly how many bits, around 10, 12. And for each bit, we've counted the number of ones and the number of zeros. So we basically need to turn this into two numbers, our epsilon and our gamma. And I guess we can just write, sure. I mean, it's a little bit, I think, lame, but we could say it's, you know, multiply together the results of calling epsilon and gamma on this. And so this will compile, except we don't have gamma and epsilon defined. So we'll put them as part of part 1 for now. Maybe they need to be used in part 2, maybe not. Epsilon is epsilon is make number of is epsilon, and we'll write that function in a minute. I'm just wishing it exists for now. Gamma is make number of not is epsilon. And finally, we need is epsilon is a function from freak, single freak to int. Freak is, now what is, how are we defining epsilon and gamma? Gamma is the most common bit and epsilon is the least common. So one's freak greater than zeros freak. Yeah. I don't think it would be any simpler with arrays. I think we could, I mean, lists are so much easier for everything in Haskell. I'm sure I'm making this more complicated than it needs to be. I'm not sure where you would propose putting an array. Lists are like definitely. Maybe you're talking about instead of my freak type? Maybe. But I like it. And finally we have make number selector, I guess, is a function that takes freaks and it's going to call do I need, I guess this should be a function that so we have a selector function and a set of frequencies. And we need to call as number of map some function that's related to the selector. mkbit selector over freaks. And as number, no. Make bit is the thing I still need. Make bit of true is 1. Make bit of false is 0. Oh, I spelled gamma wrong. Couldn't match int with list of freak. Oh, I did something terrible now, I'm pretty sure. What's wrong here? Oh, right. I just didn't change the input here, the output type. So this actually compiles. That's pretty cool. I guess we'll try running it, see what happens. We got a number. I'll take it. We'll see if Advent of Code likes this number, and if not, we can make fun of me for making everything overly complicated. That's the right answer. Cool. So that's a relief. So let's, before we commit this, sort of walk through what all this stupid nonsense that actually happened was. I feel like it did kind of get away from me here. It's a bit like there's a lot of work to convert to these ones and zeros and freak types, and you know, was it all worth it? Who can say? But so the basic process that we ran through here, you can see, I think, mostly by like reading the file upside down. We take the lists of binary integers and we transpose them so that we can look at them in a columnar fashion instead of a rower fashion. And we map bit counts over that, turning each, you know, each column turns into a frequency count of the bits in that column is what we get out of this. We have a frequency count of the bits in the column. And then, like, computing epsilon and gamma from that frequency count looked way more complicated. Turned out to be way more complicated than I thought it was going to be. I didn't think I was going to need 6 helper functions here, or 5. But the idea was I defined epsilon and gamma as 2 different functions which take a list of freak, having counted the column, right, and producing a number. And they both delegate to this make number function that I said, okay, these are basically just 2 special cases of turning a list of freak into number. And is epsilon is how I decide Oh, you know what? It would have been simpler, I think. Yeah. Well, I don't know. If we wanted to, like, really... We could have done this, right? I don't know. I'm not going to do that. But I think we could have avoided a little bit of going into Booleans and then back out to zeros and ones. So is epsilon just says, okay, if the ones are higher, if there are more ones than zeros, it's an epsilon number. Otherwise, it's a gamma number. And so given one of those selectors and a list of freaks, I can produce a number by converting each freak into a bit using the selector, either a 0 if it should be a 0 or a 1 if it should be a 1, and then calling bit count or as number, which we wrote a while ago. So I don't know. It definitely could have been cleaner, but I'll take it. Day 3, part 1. So let's have a look at part 2. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen scrubber rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers and consider just the first bit of those numbers. Keep only numbers selected by the bit criteria for the type of rating. Okay. If you have one left, stop. That's the answer. The bit criteria depends on which type of rating value you want to find. To find oxygen, determine the most common value in the current bit position, and keep only numbers with that bit in that position. For CO2, the least common. Okay, so frequency is still actually quite useful. My frequency count. And so is transposing, but we can't just do that. So it talks about working with numbers. Which for a while had me thinking we're going to have to consider both a column and a row type view of things. And I guess we sort of have to. Do we? If I have like, okay, let's suppose that I've kind of filtered things down a bit. I have like, you know, I've got, oops, I can't write 2s and 3s in here. That's not allowed. So say these are the 3 numbers that I'm still supposed to be considering. I can decide, based only on the first column, which numbers to keep, right? That's sort of the whole point of this thing. I'll keep just the ones that have a 0. I guess computing the frequencies is not going to be that useful exactly. But okay, suppose I didn't use my whole frequency thing at all. If these are my 3 numbers, and I transpose them, then I have a list of 3 bits left. Yeah, I think we're just going to write this recursively, basically. I don't know how to just transpose text in Emacs, sadly. Otherwise, I would draw it out. But we can basically look. We'll have 3 lists, and we can say if the list is, well, we'll have a list of lists, and if the list is of size 1, then we know there's only one number left. No. Yes, if there is only one list in the list of lists, then there's only one left. And then I want to filter the list of lists to be a smaller list based on the frequencies of looking at that list. Now, I guess the input must be arranged so that there are never any ties? Right? Because if they gave us, like, this list, what am I supposed to do, right? Nothing. It's impossible. Ah, no, it does say. It does say. If 0 and 1 are equally common, keep 1s. Here, if 0 and 1 are equally common, keep 0s. Okay. So is there some way that I can think about these two? I mean, they're obviously very closely related. Or this one sort of seems to have, they seem to have 2 parameters, right? This is saying keep most common and also tie break with 1s. This says keep least common and tie break with 0s. Is there some way to view those as like just a single parameter, which would be sort of nice? I mean, I kind of just like want to write it out the least interesting way possible, and then try generalizing or something like that. Not generalizing, but if I find repetition, then like do it. Get rid of the repetition, basically. So we have a freak, which is still useful. So let's write a function called scrub. And you know what? Let's just implement oxygen scrubbing. And we won't even think about the way that we're going to parameterize it to do CO2 scrubbing as well. And once it's written, we can see where are the holes that we can turn into function parameters. So scrub, oxygen scrub, is going to be a function from list of bit to int. Right? Yeah, eventually it's going to return an int. So oxygen scrub, though, is we're going to, at some point, we're going to get out a single list of bit from this. So it's as number composed with go, where go is like the actual recursive function that produces the lists of bits. Is the input small? I haven't even looked at it. It's 1,000 things. I mean, that seems kind of like a lot. I don't know if your 10-year-old brother would be that excited about it either. Where go is this function that's going to take a list of bits. You could run, I don't know, you could have him do the one of the example inputs from here somewhere. This. Where go of a single list. If I have just one list of bits, then that's one. It has succeeded. It has conquered all the others, right? And we'll just return it. Otherwise, go of nums is okay. Let's take this to freak out. To freak is a function from bit to freak. Let freak of z. How did I find it as ones and zeros? I did, right? Yeah. Well, let's just say let freak equal fold map what did I just call that function I moved out? To freak? To freak composed with head over nums. So we're going to take the first bit out of each number, convert it to a frequency, and then fold map combining all the frequencies so that we get the total frequency across all input numbers. What else do I need after doing that? I found out how common each bit was. And I guess in this case I'm looking for, let's let is 0 most common equals zeros. Let's say is 1 most common. Oxygen is the one that cares about ones, right? I'm sorry, I'm referring to the problem statement here. Oxygen, find the most common value and keep that. If they're equal, then keep a 1. Okay. So is, let's say 1 most common is 1's freak greater than or equal to 0's freak. That's our tiebreaker. We're using the greater than or equal to there. I have a function somewhere that turns a Boolean into a freak, don't I? It's here. Okay, so let's pull this out as well. Make bit of is 1 most common, cons to go of remainder, let's say. Remainder if is 1 most common will be filter equal one head of nums. And otherwise, it'll be the opposite of that. There's too many equal signs there. This looks like so grotesque. I hate it. It's not very like. Okay, so let's just test this real quick on the input they gave me, right? Or even like a really, really simple input. So say we wrote oxygen scrub of 0, 0. I'll just write up my own simple input. 0, 0, 1 and 0, 1, 1 and 1, 0, 1. So, like, what should this produce? I just kind of wrote it out randomly. So there are more zeros. The first bit will be a 0. And in the second, and that means we'll remove this number from consideration. We'll be looking just at these two. And those are tied, so we're going to keep only 1s. So it's going to be this. It should be 3, right? Nope, it's gone. It's horrible. Why? I never made the nums smaller. That's why. Now we get 3. Okay. And if we were to, you know, make the tie go on longer, this would be 1, right? Yeah. Okay, so this looks fine. This is the oxygen scrubbing function. And obviously, most of this can be reused for whatever the other kind of scrubbing is. CO2 scrubber. We keep. I'm like, not performance anxiety exactly, but I'm just like looking at this and I'm for some reason feeling overwhelmed, even though like this isn't like that hard. I'm like, why don't I just copy this whole thing and change all the numbers to get the other answer? Which is obviously not the right way to do it. Like, it's really these 4 lines that are different, and not even all of that. Is one most common, so remind me how you do this, the CO2 scrubber. Consider CO2. Find the least common value in the current bit position. And if there's a tie, keep values with a 0. So isn't this like... No. Well, okay, so let's suppose we looked at one iteration of this. If we ran both CO2 and oxygen on just one input, on all the inputs at once, just for one step, we would split the list in half. Half of them, the ones would go to one side and the zeros would go to the other side. And then at that point, the computations on them would be completely distinct. So we can't like reuse computation across them or something. Least common. What do the colors in OBS mean? I'm just like, there's a light that's green sometimes, it's red sometimes, it's yellow sometimes. Is that my like kilobit? It's next to the kilobits per second, and it's only here when I'm streaming, not when I'm recording. Is it some sort of like bandwidth indicator? I don't know. Obviously, kilobits per second is a bandwidth indicator, but what does the colored light mean? I don't know. The least common value. So, I mean, like, in some sense, I want to like take this and invert it, right? But I don't really, because if zeros are, I want to write like that, right? If ones, I don't know why I'm so confused about like what it means to be least frequent. So you know what? Let's just write out the CO2 scrub again by copying this. This can be the kind of way to like wind up with a copy and paste code base, but can also be a way to like find, you know, if you've written something 2 or 3 times, then you can see where the abstractions and the holes in it are. So is one, we want to write here now least common, basically, right? And that should be, how do we break ties? I still don't understand. Keep zeros in the case of ties. So one is least common only if there are strictly fewer ones than zeros. Because if they're tied, we should pretend 0 is least common. Not pretend, but that's what we should decide. And so if one is least common, then we filter out the ones, and that's the remainder. Otherwise, we filter out the zeros. So, in fact, all I did here is I changed this variable name, and I changed a greater than or equal to a less than. That's the only difference. Everything else is the same. So what we can do then is say scrubber is a function from int bool. You give it a function from int to bool, and it gives you back a function from list of bit to int. Scrubber op equals as number go, and then we just copy all of this. And here, we just use op. And so now oxygen scrub is just scrubber of greater than or equal to, and O2 scrub is a scrubber of less than. So this compiles. And we still get 1 for that value, and we still get 3 for this value, so I don't think I broke anything. Okay, finally. It took me forever to like see where the holes were there, and it was just like switching greater than or equal to less than. So now we can write part 2. Input to int again, and it's just, again, we have times applied over oxygen scrub and CO2 scrub. I think that's it. That's the whole definition. Okay. Run. Empty list. You got me. Empty list. It's a trick. Why? Well, okay, first of all, we shouldn't call this is one most common anymore. We should call it is one most common. We should rename it to keep 1. Okay. Where's the empty list? I mean, presumably it's coming from this call to tail, right? Oh, shouldn't it should be map tail of nums, right? Am I crazy? How was this legal before? I guess tail and map tail have kind of the same type, don't they? Zero. Okay, that's not likely to be correct. All right, well, let's try their example input first. That's sort of what they're for. So I'll copy this and put it into test.text. And we will go back to main and... Oh, that's supposed to be in a different place, isn't it? Move source test to here. And if we say here, test.text. I'm piping input, but it doesn't matter because it's ignoring it. So we get 341. Okay, well, I'm sorry, I'm reading the problem statement now. Considering the 5 zeros and 7 ones, the most common is 1. This is Haskell. It says so in the video description, I hope. Stream title? I don't even know what the right word is. Final 3 bits are 110. Gamma is 22, 198. Like, these numbers are not at all like what I got. Oh, because I'm looking at the first half of the puzzle, you idiot. Okay. And what about the example? Using the same example diagnostic report, should be 23 and 10. Well, okay. I don't have a very good way to like test part of my input, part of my process, do I? I just have this black hole that I feed inputs into and get an answer out. So I guess what we can do is, for the moment, say part 2 is oxygen scrub and see, like, are we getting the right answer for either of these? We got 31 for oxygen. We were supposed to have gotten 23. Okay, well, I guess we need to play around a bit more in the terminal to see where things are going wrong. Kind of stinks that Scrubber returns an int and we can't introspect the list of bits that it came up with in the meantime. So let's... Yeah, I agree. Today is a bit harder. I'm kind of making a meal of it for sure. Let's actually just define our test input in this file. We'll just say that it's I'm just going to copy it from here basically. It's hey, wait, why didn't it go? Why didn't it keep going? Yes. Yes? Okay, I don't know. I hit spacebar too fast or something? So if we then said prepare test input, it gets this thing. Wasn't I supposed to use less than or equal to CO2? I don't... Was I? I don't know. It doesn't matter because we're wrong about oxygen also. I think I'm supposed to use less than, right? Because if one... We were looking for the least common value and tie-breaking with 0. And I'm saying if 1 is strictly less common than 0, we should keep 1. Which means that if they're equal, then I will keep 0, which I think is what I was supposed to do, right? I think that's right. Okay, and if we said oxygen scrub of pair test input, like, we'll get the wrong answer, right? 31. And that's wrong. But like 31 is an interesting number, isn't it? Did I forget to transpose something? Is that all that happened? I think that is all that happened. I forgot that I need to look at the... No, because I have a list of numbers. And I'm looking at the beginning of each of them. So I think that's right. But 31 is very suspicious because that's like 5 ones in a row at the end of a number and nothing else. Or five ones, isn't it? Something like that. So let's just like look at this first bit by hand. We have a 0 and a 1 and a 1 and a 1 and a 1. Like we have 1, 2, 3. Oh, can you see my cursor? You can't. Okay. And we have 1, 2, 3, 4, 5, 6, 7 ones. And the number of zeros we have is 1, 2, 3, 4, 5. So indeed, we should keep the ones. And in the second position, we have a 0, 1, 2, 3, 4, 5, 6, 7. We have 7 zeros, and therefore 5 ones. The second bit should be a 0, but it's not. Okay, so let's try to change Scrubber so that we get out the actual list of bits that it came up with. I assume, like, I know what they'll be, right? But, and also, I guess, worth checking, there are 5 bits in, yeah, so it correctly winnowed it down to a single 5-bit number. But for some reason it made all of them equal to 1. Oh! Wait a minute. My map tail is in the wrong place. I'm taking the first bit off of all the numbers before I just look at the beginning of, before I look at the first bit to decide which one to keep. So first I need to go like this, map tail, like that, right? Now if we go back here, we get 23, which is the right number. If I say CO2 scrub of this, I get 10, which I believe is also right? Yes. Okay, phew, crisis averted. So let's run this. Won't work because I'm pointing at my test input. Oh, but I also have to fix this as well. Multiple definitions in part 2. Okay, don't okay. All right, we'll get there. We'll run the program eventually, and it'll run. And it's a number. It's the right answer. Okay. Okay. I mean, it wasn't pretty at all. There were some parts of it that were pretty near the beginning, but they were also verbose, and so nobody in the chat liked them. I had some hecklers. But, I mean, this is, like, okay. This... I really don't like this part. Keep one... Like, it's so much repetition here. Alright, I'm not going to mess with it, though. Maybe I'll refactor it some other time. think, yeah, this is... I don't quite want to commit this because I've added this weird part 2 thing, or this test input. Let's edit the diff before we add it. Commit-m day 3 part 2. And throw away that extra junk. Thank you everyone for your adoring cheers in the chat. I feel like if I made it like I'm like wiping sweat off my brow, right? And it shouldn't have been such a hard. Hey, how come my menu bar is back? Ugh. All right, whatever. Maybe it closed Emacs and reopened it. I don't know. I feel like I'm. I don't know. Like a musician, right? Who plays a very easy song, but plays it in such a difficult way that they're working up a sweat and the crowd is holding their breath in. That's how I feel about this problem. Like, I feel like I made it so hard that people are cheering for me, but it was not really that hard. I don't know. The people who are cheering, though, some of them are people who like struggled to finish it today, so maybe I shouldn't belittle their efforts by calling this an easy problem. Maybe it's just deceptively a little tricky. Part 2 was not trivial. Part 1, I spent a lot of time talking and writing, but the actual, well, okay, it kind of sucks too. All right, I think I'm gonna head out of here. I should be able to stream tomorrow night as well. I should be able to just set the stream for 9. Although I'm getting my booster shot tomorrow, so maybe I'll be exhausted. I don't know. We'll see. Tomorrow morning. So a little complicated if you don't know some of the tricks of the language. Well, I knew too many tricks of the language is what I feel like happened to me here. I mean, there's obviously ways to improve this by getting rid of some of the duplication, right? And don't I reuse like fold map 2freak dot head somewhere or 2? No, I just fold map 2. Where's my other fold map? Just fold map 2freak. Like, actually could. I don't know. Whatever. Yeah, the instructions are tricky. I agree with that. I think this ought to make things at least a little bit clearer. Right, so now all the duplication here is gone, and we just have this kind of awkward switching on a bool. Let's confirm that this still works. That number looks about the same. Was it actually the same? Yeah, I mean, recursion is fine. I mean, that was what I did here, right? Like, I think that one thing that people might kind of make harder than they have to is, well, okay, so there's some discussion in the chat about not understanding the instructions. Let's step back and read the instructions again. The bit criteria, so keep only numbers selected by the bit criteria for which you are searching. So you don't have to remove any bits if you don't want to. If you want, you can keep the whole number around and look at the first bit of all the numbers, then the second bit of all the numbers, and then the third bit of all the numbers, right? That's fine. And I feel like that's the solution a lot of people will take, especially if they're working in a language that has, arrays by default rather than linked lists by default. Because it's expensive to throw away a bit in a number, but it's cheap to index a number. So if you were writing this in Python, I think you would quite justifiably just keep the entire number and index by bit. But I think it's in some sense more elegant to, when you're doing this recursively, to say, well, I have a list of numbers, and by looking at just the first bit of each number, I can compute one bit of the answer. And then by looking at the remaining bits of all but the first bit of the numbers that I'm not throwing away, I can compute the rest of the bits. And that's kind of the recursive approach. I think there's a totally fine iterative approach where you track an index, you loop through a list of numbers, or a list of bit, or whatever. And you never modify any number. You just throw them away until there's only one left, and then you read off that number as the answer. I think that's a totally reasonable iterative solution, and would be better in Java or Python than doing something recursive, just because the language is more suited to it. Throwing away the first bit of the first item in a list sucks in languages where you have like arrays for everything, or lists, which is what Python calls them. They're like vectors or whatever, dynamically sized arrays. And I mean, obviously efficiency doesn't matter here, but because it's inefficient, the language doesn't make it very nice to do it. I guess Python has slices. You could write the recursive, but Python hates recursion too, so what are you supposed to do? Using the numbers from the first bit. I don't really understand the problem Quentin ran into, but okay. So I guess I'm done implementing this. I've sort of talked over things. Is there anything else I want to draw our attention to? I guess for any late joiners who are interested in like Haskell and what you might call some type theory. What does Python call linked lists? You just don't use them. You would be like, I don't know. Nobody would use a linked list in Python. That's the answer. Right? Like, I don't know. I'm not a Python expert. But they're just like not a thing the language encourages you to use. Just like in Java. Why would like linked lists? Nobody uses those. They're in the standard library. But everybody uses array lists, or if you use Guava, you can use immutable list. And both of those are just array backed. People who program in Java, I assume these claims are true because smart people make them. But I don't have evidence to back it up myself. The claim is that, like, okay, yes, linked lists are cool if you're going to remove stuff in the middle or whatever. But if you're just like going to be appending to the list for a while, like, I don't know, you take so many cache misses when you use a linked list that it's better to just like have a slightly inefficient operation that you amortize over stuff with an array list instead. Yeah. So if there's one more thing that I wanted to like go over for anybody who missed it, it was like the idea of semigroup and monoid, which I don't really have a lecture prepared on, but they're just a super, super common thing in every language, right? Tons of data structures are monoidal. And if you recognize that structure is there, it might make you happier, right? And so, I mean, we can formally say that a monoid M is a set of three things, right? It's a type T. We're just like being overly formal. An empty element and a combine operation. Where then there's a couple laws, right? The laws are like, combining anything with empty is just X. It is the thing you were combining. Combine X with empty is also X, and a combine X with combine YZ must also be the same as combine X, Y with Z. Is that right? So this is like the entire definition of what a monoid and a semigroup are. A semigroup is like, it doesn't have to have the empty element, and when you add monoid, you get empty. But so many things are monoidal, right? Addition, multiplication, these are monoidal structures over integers. Concatenation of lists is a monoidal structure. Composing functions is monoidal, where the identity function is the empty element. I saw an interesting video of like introducing these structures to a newcomer, where you can talk about, well, what about addition under a modulus, like adding up numbers on a clock? That's monoidal as well, where empty is like 12 o'clock. And, pretty much any... there's just so many things you can do that have a monoidal structure. And you can write functions for things like, okay, if I have a list of values of some monoid type M, just like combine them all together in some order, I don't care what order. And that's fold map. And things like find me the first item in a list is a semigroup. And if you like lift it into maybe, where like find me maybe the first element in a list, but nothing if the list was empty, then like that's a monoid. And find me the biggest element in a list, likewise, is a semigroup. And if you list it into maybe, it's a monoid. And so you can take these functions like mconcat, which takes a list of monoidal things and combines them all for you. And like that just works for all of any type you write that has monoid. In my case, I used fold map, which takes like a list of A and a function from A to B, where B is some monoid, and it like computes that value over your list, combining all the results in the obvious way. And you like don't have to worry about what the obvious way is. You just make your type of monoid, and like it's just handled for you. So I don't know. That's my little spiel on monoids. They're like the best. Computer science is all about finding ways to compose things instead of having to write a bunch of special cases. And monoids are the simplest kind of composition for data structures that I'm aware of. So I guess that's today's lecture. I think I'm going to head out. Thanks to those of you who showed up, and also to anybody who hasn't showed up yet but will be watching later, I suppose. I don't even know if there's anyone here still, or if you all left after hearing me blather on a bit. Anyway, so I plan to see you tomorrow, probably around the time the puzzle gets released. Thanks for watching, and I'll see you next time.